What current flows through the 2 ohm resistor? Okay, so in last video, we saw for the current in the 6 ohm resistor. In this video, we're solving for the 2 ohm resistor. The difference between the 6 and the 2 ohm resistor is the 6 resistor is in a parallel system, and the 2 ohm resistor is in a series system within a parallel system. So it's like a step further. So it's gonna be a fun problem to do. We want to recall that the OG formula for circuits is going to be equal the voltage equaling to current of the circuit times resistance of the circuit. Okay, the next thing you want to realize is that in a series circuit, you have the same current. In a parallel circuit, you have the same voltage. Okay, which means that in a series circuit, the current here, they're the same. Therefore, in order to find the current of the whole circuit, you're just going to be adding one of these to this, because these two are the same, so it wouldn't make sense to add two of them, okay? They're the same current. So you can pick either the 2 ohm or the 4 ohm. I'm just going to pick the 2 ohm because we're solving for the 2 ohm resistor. So 2 current of the 2 ohm plus current of the 6 ohm. Okay, will give you current of the circuit. Now, the next step is to figure out, okay, what pieces of information is going to be helpful for us. We know that in order to find the current, you're going to have to divide the resistance on both sides. So you have the voltage over resistance of the circuit. So we know that the voltage is 8. So this is 8. And we know that in a parallel circuit, we will have the same voltage. So now the next thing you want to do is to find the resistance. To find the resistance, you want to figure out, okay, are there different types of networks in this circuit? Yes, there are. There's the series network and then there's the parallel network. So you're gonna have to find the series and then parallel. But see, if you look at this series is within the parallel network. So what we want to do is we want to find the series first, then use whatever number we find here to find the parallel of these two. Okay, so I'm going to show you so you know how to do it. So let's find the series first. The series resistance is going to be R1 plus R2, which it's 2 plus 4. So our R series is 6. So these two accounts for 6 ohms. Okay. Now, we want to find our R parallel. our R parallel, the equation for R parallel is going to be 1 over R parallel is equal to 1 over R1 plus 1 over R2, and so on. Okay. Now, applying this to our circuit, we have 1 over R1, which is our 6 ohms, plus 1 over R2, which we just solved from our series over here, also 6 ohms, because it's still within the parallel circuit. So, bring out your calculator, 1 over 6 plus 1 over 6, you get 1 over 3, which is 1 over R parallel is 1 over 3, which means that R parallel, our resistance for a parallel network is going to be flipped. Flip of 1 over 3 is 3 over 1, so it's 3. Crucial information. Since we added this into this, not only will this be our R parallel for this, it's going to be the R total. It's going to be the total resistance. So you can rename this as R total is 3. So knowing that R total is the same as R circuit, so let me rewrite this again. R circuit is going to be 3. So we could write 3 over here. Plug 3 into here. Now, that means that we could solve for our I circuit. So let me erase all of this and solve for I circuit. I circuit is equal to 8 over 3. 8 over 3, which is 2.667. So let's say it's 2.66, okay? The whole thing is 2.66. But we don't want to find the whole thing. We want to find only the resistance, like the current flow that goes through the 2 ohm, which means since 2 ohm is the same thing as 4 ohm, we want to find the current that is the current subtracted by the current of the 6 ohms, because it's going to give us the current for both the 2 and the 4 ohms, because they're the same current. Therefore, we need to find what's the current flowing through the 6 ohm resistor. And in the last video, we did solve for that, but in this video, we're gonna start from the beginning, okay? So to find the current that goes through the 6 ohms, you want to set up this OG equation in respect to find the 6 ohm current. So we have voltage of the 6 ohm is equal to current of the 6 ohm times resistance of the 6 ohm. Voltage, we know that in a parallel circuit, this is in a parallel circuit. Parallel circuit have the same voltage. Therefore, because we have the 8 volts over here, it's going to be the same because this is a parallel circuit. So voltage is 8 is equal to I6, which we don't know, and the resistance. Resistance, we already know it's 6 ohms. So there we go. And to find the current of the 6 ohms, you just divide both sides by 6. You get I of the 6 ohms, current of the 6 ohms is equal to 8 over 6, which if you plug into a calculator, 8 over 6 is the same thing as 1.33. Around 1.33, so we're just going to say it's 1.33 amps. This is also in amps, okay? So now, to find current of the 2 ohm, let's subtract I sub 6 on both sides. So current of the 2 ohm is going to be equal to I circuit subtract I sub 6. We have our I circuit right here, and we have our I sub 6 right here. So what do? We plug and chug. So I sub 2, current that flows through the 2 ohm resistor is going to be equal 2.66 minus 1.33, which is going to be equal 1.33. Yep, 1.33 amps. So there you go.